Okay, so this is chapter 5, and I want to get this out of the way before we do anything else. There's 3 topics, and the first one is ratio, and then a little bit later they talk about rate, and then a little bit later they talk about proportion or proportions. So this all goes together. What I want to do is remind you what ratio is, because if the word doesn't click, then we need a way. So here's our memory device. There's the word. You ready for this? A ratio is nothing more than a fraction. But we're not going to be doing, terrible things with them. What they are fractions. And so we may say the ratio is 3 to 12. And so we say it multiple ways. We might write it like this. We might write it like that. And once in a while, and I haven't seen too much of this in this book, but they used to use this symbol for 3 to 12 as a ratio. But I think they're favoring this the most. And so these are different ways to write a ratio. But in general, if you want to say for some reason it's 3 to 12, we already have the skills needed to deal with this. And what they'll want you to do is write it in simplest form. So they'll say, well, here's the ratio 3 over 12, simplify it or do something with it. And of course, the result is putting it in a simple fraction, okay? Now, I did notice in this first section, 5.1, they had various problems. Let me see if I can find one for us. Oh, they did use the word two. Let's do that. 250 to 100. And so write each the following as a fraction in lowest terms. Okay, so knowing that this is a ratio, and this is one way to say it, if we convert it to the fraction version, the first number is first, the second number is second, and then we've got that. To reduce it, I think you remember what I would do is take care of these zeros. This is instead of dividing by 10. So 10 into 250 is 25, and 10 into 100 is 10. And at this point, I can reduce it by 5. 5 into 25, 5, and then that. And as a ratio, this is the best answer, the best final answer. It's this many to this many. You can see different versions that might be helpful. If you were mixing paint, they have ratios, right? So that they get the color right. When you're cooking, they have different ratios to get the product right because you're expanding it or reducing it, something like that. And so these are clearly ratios. Now, I did see a couple that looked like this, and let me, so we're not afraid of it. Oops, it was 7/3, and this was 6/3, like that. So same instructions. You were told to take this as a fraction and simplify it to lowest terms. And so you could do it 2 ways. One way is to write it as a fraction like this. But on the other hand, you might say, oh, wait a minute, this is divide, isn't it? And so this is 7/3 divided by 6/3. And that might get us there quicker because this would have to be converted to this anyway. And so then you say, oh, okay, let me see if I can remember what chapter was that. I had to do something with this in order to get a single fraction. And what you had to do was copy the first number, change it to multiply, and invert the second. So the division problem turned into a multiplication problem. At this point in time, we try really hard to reduce anything that will. And I'm going after those threes, if you don't mind. 3, 3. So the final result of this mess is 7/6, or 7/6. And I would leave it like that as a ratio, not a mixed number, but as a ratio. I did see a few that were slightly worse than this one. And so and this is going to be review. It's a ratio, which is a fraction. So this is telling us to divide. So it's 5 1/4 divided by 1 3/4. Well, if we kind of go on what we were doing previously, we had simple fractions, and then we did an invert. And so this would be the first thing you would have to do to make this simple fraction. 20 and 1 would be 21/4 divided by 4, and 3 is 7/4. At this point, you want to cancel, but you're not allowed with division. You have to turn it into multiply first. The front number stays the way it is. The second number, the back number, inverts, and it turns to multiply. And this is 4/7. And I believe I can cancel the heck out of this one. I'm going to take out the 4s. And then the 7 and the 21, I can divide by 7, and I'm almost there. 7 into 21 is 3. This is 3/1. And I believe, let me just double check that. They will leave it like that because they're looking for a fraction
So
that has a
Professor
numerator.
Patterson,
Yes.
in this chapter, in the XYZ homework, there were two problems, one after the other. There was a similar one. I don't know if it was exactly the same, but it did allow me to do like 3/1. But then the next one had a similar answer and it didn't accept it as a fraction. It wanted a whole number.
Oh, darn.
But yeah, anyway.
If you can recall, before we're done today, which two problems it was, maybe we can take a peek at them.
Okay.
But this is what I don't know if you remember making orange juice with frozen. So you'd have a container. So there's the frozen can of orange juice. And so I think, as I recall, it was 3 watt. This was the water. Was it, anybody remember this? I don't do this anymore. Can of juice.
Yes, I remember.
Anybody remember it was 3/1?
Yep.
I remembered numbers and nothing else. So if that was the case, and that's what they wanted, the ratio of 3/1, if you just said 3, it looks like all you're going to do is put water in your jar.
Okay, that makes sense. Yeah.
And so it's 3 for this and 1 for that. And so it was just, I like that analogy, and I don't, do that anymore, but does that make sense? So it's this much to that much. And so it really needs that second number.
Yes.
Okay.
Thank you.
Oh, you're welcome. And I know XYZ is finicky. Here's the last one, or the last type. They had the fractions where it was either a simple fraction to another fraction or a mixed number to a mixed number. And so you had to rely on what we did earlier. But in this case, what are we going to do with this? So I suggest you write it in this form. So it's 0.21 to 0.03. Now, the good part about this is because they're both decimals, we can clean this up. This is not good. This is a fraction with decimals in it. But there's no problem here, because what I'm going to do is to get this to be a whole number, not this crazy decimal, but to get it to be a whole number, I'm going to multiply it by 100. So I'm going to multiply this by 100 and this by 100. Now, if you remember from, I don't know which week it was, when you multiplied by 100 on a decimal, it just was a decimal shift. And so multiplying by 100, 2 zeros, made it 2 decimal places. So this is just going to be 21. And when I multiply this one by 100, you've got to do the same to both so that it stays the same basic problem. 1, 2. 0, 0, 3 is 3. So what I've done is taken a mess and turned it into something good. Because with whole numbers, I can definitely finish this problem. Whereas this, what was I going to do with it? I didn't know. Answer 7 to 1. And to me, that's the ratio that would be best represented by this problem. So let me just do another version of a decimal, and then I think I can move on. Well, that's not what I wanted. I wanted this, but I didn't see it in the work. But if for some reason you had this one to that, this one needs 2 decimal places, so it really, really needs to be multiplied by 100. This only 1 decimal place, 10. You can't pick and choose like that. So if one of them needs 100, that's what you're going to do. So I'm going to multiply by 100 over 100. I'm just writing that. You don't have to write that. So this would move 2 decimal places, which would give me the number 6, because the decimal's now here. And this would have to be 2. So in a sense, I went around the 2, but then I have to add 1 0. Okay, so you have to match it. You can't be multiplying this number by whatever and this number by something different just because it suits you. You have to be fair, same, and then you've got this is equivalent to that. And so in this case, I'm going to divide both of them by 6. 6 into 12 is 2, and 6 into 0 is 0. 6 into 6 is 1. So I would call that my final answer. So you've got to, I think most of the problems, it ended up being the same number of decimal places so that you automatically multiplied by the same number. But it could happen that one was different than the other, and you've got to clear the larger number and so on. And so that's that. They had this one too. And then I'm off at this section. So one's a decimal and one's not. I think this is your best approach, is to write it like this as a fraction. You say, oh my gosh, well, this sort of correlates with that. I've got to multiply this by 10 to get a whole number. So I end up multiplying both of them by 10. So 10 for this one would give me a 12 again, but I have to be fair and multiply this by 10. So either I say 10 times 10 is 100, or I say multiplying by 10 shifts the decimal one. Either way, it's 100. And so now I've got something that's without decimals and I can deal with it. And so I'm going to divide, I don't know. I think I'm going to divide by 4, if that's okay with you, and see how much trouble that gets me. 4 into 12 would be 3. And 4 into 100, think of money, would be 25. And that's reduced as much as it's going to be. Is that okay? Okay. So that's that first section. And I think it'll work out fairly well, except for the things going strange with XYZ. This next section is about rates, and they also call it unit pricing. So rates are just ratios, and most of the time they have labels. So for instance, so if they wanted the ratio of 125 miles to 5 hours, it always makes sense if you can say this in a simpler, smaller, more concise way, then that's good. This fraction line translates into the word per. And so there's 2 parts to this. One part is to simplify this if humanly possible. And I set up a problem that would divide nicely. 5 into 12, you can do it on the side if you want. But 5 into 12 is 2. And then 5 into 25 is 5. So this part here, the number part is 25. Now, technically, this fraction line kept going. And so you would write it as miles like that. So the words will not cancel because miles and hours are 2 completely different things. I'd cancel them if I could. I can't. So I have miles per hour. And so I've simplified my number and I've written the unit that's appropriate. So there's all kinds of examples where this might show up. So let me just make something else. If I paid $2.50 for 5 pounds of something, I don't know, vegetables, then I might be interested in what does it cost for 1 pound? And that's actually a unit price. So this is the way it looks. $2.50 divided by 5 pounds. So again, there's the number part of this. And so 5 into 250 is just 50 cents. And so it's that per pound. So it's 50 cents per pound. Technically, it's for 1 pound. Does that make sense? So this makes more sense because then I could buy 7 pounds and it would be easy to compute. This was helpful to tell me what's the going rate here, but this is the unit price. And you may have noticed at some point in time, grocery stores started putting it next to items so that people didn't have to do the silly division. And it became law. They want you to see the unit price, and so that you can, judge one product to the next. I don't see that as much anymore, but at one point it became law. And so people like to compare, because it was it was different sizes and you were interested in the best deal. So I think if you just remember that there's the number part to deal with and the unit. And so this is 50 cents per pound for 1 pound. I put the 1 in there just for emphasis. I think that will probably work out. What I wanted to do, oh, here's something, let's do it this. This is 100 pills. I wonder what kind of pills they are. And it's $5.99. Okay. Find the unit price. And so they were comparing 2 items, but let's start with this one. The cost was $5.99 for 100 pills. Does that make sense? So let's do the number part of this. What happens when you divide a decimal number by 100? Now, we were multiplying a minute ago where we would move the decimal to the right to make it simple, but I'm going to show you dividing, and it's sweet as multiplying. When you divide by 100, 1, 2, this is why the metric system works, by the way, 1, 2, then instead of moving it to the right to make a bigger number, what do you think you do? You move it to the left. Now you could divide this out and take all that time to do the long division, but the truth of the matter is, it's the same rule, except division makes the number smaller, and so you go to the left, whereas multiplication made the number bigger, and so you went to the right. And so I'm going to put that number down, the whole thing actually, even though okay, and so sometimes you see prices where it goes further out than just the cents. This is for how many pills? 1 pill. Well, okay, it's around 5, closer to 6 cents a pill, right? Some pills cost more. Let me see about the other one. The other pill, they were selling for 225 pills for $13.96. Okay. So I may cheat and use my calculator because I feel tired, but basically this is $13.96 divided by 225 pills. And in the interest of time, I'm going to find it and just do it. 13.96 divided by 225. Oh. Okay, I did this. So 0.06. So this is actually over 6 cents. This is actually a touch under 6 cents. So if it mattered to you about this, this cost less by a touch, not much. I don't see a big deal here. But you could then compare, this is how you would compare your pricing on these 2 items. And as far as I can tell, they're about 6 cents a piece. And sometimes I don't worry about things like that. Okay. There's 2 more sections, and this one may seem odd, but it's, I think you've already done problems like this before.
Ms. Patterson, I have a problem from 5.3 that I didn't understand.
5 what?
5.3, the chapter
Okay. All righty.
is,
Yeah, let me start this and then I'll do your problem because this is perfect timing.
thank you.
So let's say I had 3x equals 15. This whole section is solving equations by division. It's a piece of cake. There's nothing here, so you assume it's multiplication. So can you tell me without a big fuss what the x has to be, the missing number? There's only one number that will make this add up, multiply to 15, isn't there? And so this must be 5.
Mm.
But the simple step to get to it, which is because this was the x was multiplied by 3, here's what I'm going to do. I'm going to divide by 3 on this side, and I'm going to divide by 3 on that side. Now, why did I do that? Because 3 divided by 3 is 1. And 1x is really x. I don't have to write all those steps, but that's x. And here's my answer, 5. And so this is something, this little cuteness is something we're going to need. And so they just do a very quick section on this. So here's the next one. What would you do? Well, we want to know what the missing letter is, which is really a number, y, and it's multiplied by 7. And so I want to really get rid of this 7. So instead of multiplying, I divide, which is the opposite. And I have to do it to both sides to be fair again. And so the 7 over 7 is 1. 1y is really y. And the actual answer appears over here. Y is 3. How does that? Is that easy enough to do? It seems like, why would you do it when I knew the answer was 3 from the beginning? Because sometimes it's not obvious what y is. 6 times what is 23? I don't believe, it's not on my radar. But if I go ahead and divide both sides by 6, like I've been taught to do, this is my answer. Like it or not, 23 over 6. So once we get in the habit of, once we see a problem, we see the letter. And so this is a little bit of algebra, no big deal. Because we see that letter that's multiplied to something, divide it and divide it. If that's all there is, then you can do it in this one step, and then you have an answer, even if it's like a little bit strange. 23 divided by 6, leaving it in this form is your best bet. Okay, so tell me what you remember from the problem, Doris.
Two
Yeah,
dot multiplication, 7.7.11. Fraction,
what do they want you to do?
fraction line,
Fraction
2.7.
line.
2.7.
And so I don't think it's 0.7, I think it's 2 times 7.
Yes, 2 times 7. I'm sorry. Yeah.
So it was just a little bit of practice, which things we did before. This is all prime factored, which is really good. And so you can clearly see what needs to cancel. And so this is back to whatever chapter was fractions. And so these were all multiply, and the fraction line is really divide. So it's a lot easier to reduce it. The 2 for a 2. Then I would reduce a 7 for a 7. And now I don't have anything
Oh.
left here to reduce. So these are ones. 7 times 11 would be 77. And 1 times 1 is 1. And without seeing the instructions, I'm not sure if they wanted a whole number, but that's all there is. It's real simple because
Oh.
it's a match for a match. It's not like a decision where you had to say, oh, what do they both have in common? These are out
So you cancel them out.
These are out in the open, and I always kind of
Mhm.
refer to these as the skeleton view of the numbers because you can see every little bit. It's nothing hiding, right? Is
Mhm.
that okay?
Thank you.
Okay. So let me keep rolling. I wanted to do this one because this last section is about proportions. And it's really, I'm hoping most of these topics seemed easier to deal with, but I don't know. But a proportion is just 2 ratios set equal to each other. So I'm going to go 3/4 and I'm going to go 9/12. This is a proportion. It's one fraction set equal to another. Now we could stare at this all day long and say, my, isn't that beautiful? And you may not be so impressed with the beauty of this. Are you impressed? But there's something clever that happens when the 3/4 and 9/12 are both equivalent. And so something interesting happens when you have a true proportion, which means this fraction is equal to that fraction. If you take this number and you take this number and multiply them, this is 3 times 12. Now I'm going to take the other direction. This number times this number. They will always be equal if it's a true proportion and if this fraction equals that. So this is 36 and this is 36. And this is what happens when you have a true proportion. Now we can again sit back and say, what a beautiful problem. But the real beauty of this is what happens when one of the 4 numbers are missing. This will solve all kinds of problems in many courses. And so let me take the same problem so that you really know what the answer is. This is the very same problem, and you don't have to go very far to remember what it was. But this is why they did the last section about canceling equations. 3 multiplied by x is 3x. I can put a dot here if you want, I don't care. But it's 3x or 3.x. That is equal to, and do not forget the equals, this number times this number. So at this point, I have an equation. An equation has an equal sign. It has something on the left and something on the right, and they're supposed to be worth the same amount. So what I would do here is 4 times 9. You know, you're always trying to make the problem easier to judge. So I took my 4 times 9 and called it 36. But here's that problem we had from the last section, and that's the only reason we did it. I'm going to divide both sides by 3. 3/3 is 1. 1x is x. And then 3 into this is 12. The other good thing about these problems, these proportions, is when you're done and you have an answer, this answer belongs here for x. And there's no reason to ever miss a one of these because this times this was 36. 3 times 12 is 36, we know it's right. Okay? So we have a way to check it, and we know it's right. So, I don't know, they talk about all kinds of weird things. But let me. Equals. Proportions work beautifully in so many cases. I love them. So whenever I can turn it into a simple fraction and left and right, and it's an equation, I'm into this. 2 times 10 is 20 equals y times 6. And when you have y times 6, in algebra terms, we always like the number first. So this is the common way to write it. Not y times 6 or y6, but 6y. And so we might as well get used to it. 6y. Now, my missing letter is on this side. Don't be concerned about that. We want to be ambidextrous. We can deal with left or right, but we do have to deal with the 6. And so what I'm going to do here is divide by 6 so that this will go away. And I have to be fair and do the same to the other side. So 6 divided by 6 is 1y. And this is 20 over 6. And you know as well as I do that 20 over 6 doesn't cut it because it would reduce. And so I'm going to reduce by 2. 2 into 20 is 10. And 2 into 6 is 3. And that's my answer for y. Now, depending on when you're in school, they used to say the letter is written first. And so they would say y equals 10 over 3. Anybody know what I'm talking about? If you did any of this before, that they favored the letter on the left side and the number answer on the right side. Frankly, it doesn't matter. And there's literally a mathematical rule that says this and the reverse of it are fine. But if, when you fill in your problem, they might say, well, y equals, and then you've got to, do it that way. So it may be that they're favoring this way, but the truth is it didn't matter. Anybody have any suggestions or comments about that? So if no comments? Tell me you love it, right? I mean, oh, geez.
Love it.
You love it. Well, that's right. If you can only do one thing, you've got to love it. So I have people help me cook. So are we ready for this one? So I'm going to just take this first diagonal. And so this is a 5 multiplied by an x. And I'm going to write it like that. I can put a dot in there to say multiply if I need to. Okay? Equals, don't forget that. This way, 0.5 times 20. Now, I need to deal with this. I need to get this exactly right. But if you think about it, you can do this out, and I will. But this is 0.5 is half, and half of 20 is 10. But let's say you didn't notice that. So you would multiply it out. 5 times 0 is 0, and 5 times 2 is 10. But it's not 100 because there was one decimal shift. And so this here, no matter how you slice it, I'm thinking a half of 20 is 10, to be honest with you. This is still 5x, but notice I'm going down. And in equations, we always go down because it's easier to see that we haven't made a mistake from here to here, here to here. And now all I have to do is I want x, not 5x. Who cares, 5x? I want x. And so I end up doing this one little step. We get used to it. Divide by 5, divide by 5. 5 divided by 5 is 1. 1x is x. And the answer is right there. And this one, they're not asking for a ratio, they're asking for a number. So the number is 2, and I'm satisfied with 2. We're not making it 2 over 1. If they wanted a ratio or a rate, I would want the fraction. I don't know if that's addressing that. In this case, see here, when I put this in, 5 times 2 is 10. 0.5, which is a half of 20, is 10. I am satisfied with this answer. Okay, it checks. And so, yeah, so that's what I wanted to do. Does anybody have a specific, we have some time. Does anybody, we could either from here or back from chapter 10, anybody have something that they've written down as bothering them?
I just
Go
get
for it.
confused with the median.
The median.
The what is it? The 3? Don't ask me right now.
Median, mode, and
Yeah.
We didn't talk about that.
Yeah, then it was asking for extremes. It's a major part of like 5.4. I cried vigorously over the question. No,
Oh, I missed it. Where?
we're in
5, 4?
chapter 10, one
Oh,
of the
chapter 10.
homework questions was this subject.
I somehow missed, I didn't talk about it. You said it's 5, at 10.5, at 10.5?
Yeah.
All right,
And
I can do that.
It was the
right
very
now.
last
That's a good
question,
one.
wasn't it?
Are you sure it's 10.5? I can
you mean
do this without
5.4?
looking at anything.
I mean, not 5. Let me look.
Or is it 10.4? Oh, we want to do this, and I don't need it, but I wanted to see where it was. Was there anything, a mean? Did they have a mean?
Yeah,
Yeah,
there was
they
mean,
asked for all
median,
3 of
and
them.
mode.
What is
Okay,
the
these are
mean?
beautiful
What is
things.
the mode? What is the median?
This is statistics.
Question 3 on
It's
5.4.
on chapter 9.
Is it 5.4?
It's 9.1
9.1?
in the book.
We haven't done 9.1.
Yeah, 5 point. Hold on, guys. On XYZ homework. If I'm not mistaken, it's 5.4 on XYZ homework. In the book, it's something totally different. I think that's what we're getting confused.
Right.
Oh.
Yeah, I'm like, what are we talking about?
Yeah, thank you. It's not
actually
just
have the
me.
book out.
No, you're good. No, so 5.4, question 3, I think is what you're talking about. If you look at the homework.
Because I'm not seeing it. And so let me just tell you what this is all about. And if there's a discrepancy, I'll take care of it. So the mean, this is statistics, is the average. So people are interested in average when they have 5 and 10 and 15. I'm just going to make it easy. So if you had 3 numbers, to get the mean, which is the average, you add up the 3 numbers, and I made it simple so that, because I didn't have a real problem to do, and divide by 3. So this actually is 20, this is 30 over 3, which is 10. So this is the mean. So we average all the time when you average your grades or something like that, right? If you go bowling, you have 3 they used to play 3 games and then you'd find the average of the 3. And so you'd add up your scores and divide by 3. Is that something you've done in the past? Find the average?
Sports, playing basketball, I used to try to do my averages for
Absolutely. Anything. So related to that, you add up the scores and you divide by the number of scores. And so that's a pretty simple thing to do.
what if
The median, and I think this is probably going to be thrown out, but this is good stuff because you'll need it sooner or later. The median, you know, in a highway, here's a highway, and sometimes they have grass in the middle, and they call this the median strip. Does anybody know that? For some reason, by driving, the median strip or in the highway is, you know, where they might have grass or something, or trees, or
Yeah, that's
where
the
you
thing
are.
the drunk drivers always hit when we go pick them up.
Oh, okay. In the median. Anyway, this is trying to help you to remember it's the middle. It's trying to help you remember it's in the middle. And so if I'm going to put a bunch of numbers down, 5, 6, 9, 10, 11, 12, 2, 3, 4, 5, 6. Let me put another 9 in here. 1, 2, 3, 4, 5, 6, 7. I have 7 numbers here. If you put the numbers that you're given in order, the median is the middle number. So this is 1, 2, 3. It would be this one. And the way to, if you have your numbers listed out like this, I had 7 numbers. And so I divided 7 by 2. So I put 3 here. And then my number, and then 3. And so that is the median. So when you have an odd number, it's really obvious. And if you're a little bit confused about dividing, you know, the whole line by 2, you know, I had 7 numbers divided by 2. I put 3 and then 3. When you're done, the number on each side should be identical. And I think I will double check this for you. But does this make sense? So the only way to judge a median is to have the numbers in order. If they're not in order, it makes picking the middle number doesn't mean a thing. So if you had 3, 5, 7, 10, if you only had 4 numbers, the median has to be the middle. Now, 5 is not the middle, and neither is 7. The median happens to be dead center of the 2 middles. So dead center of a 5 and a 7, I made this easy to spot, would be 6. So the median would be 6. Does that make sense? Median, dead center.
So when it asks, and this goes off of Sophia's question too, it asks for the, okay, so like in 5.4 on the homework for question 2.
Do you actually have the numbers?
Yeah, I was trying to, oh yeah.
If you have the numbers, read them to me.
Okay, so it says for the proportion of 1 over 4 equals 5 over 20. Name the, and this is where I'm not confused, but this is where I was like,
They did it that, okay, keep going. Go ahead. Name the what? Oh, I know what you're doing. It's not mean, median, and mode. It's, oh,
Professor, I put it in their chat because I haven't done it yet in homework, but I've gone through the book. It's talking about extremes, product of extremes and product of means.
now I make sense. Now I've got it. Okay. I
Thank
was
you.
giving you statistics because I teach statistics. I don't think that was a bad lesson, but you can let that go. They used it 1:4 as 5:20. Written in this form, which is not the form they're doing it, but it's easy to spot. It's easy to answer this. This number and this number are at the extreme. And so these two are called the extremes. This is old language. They don't teach this so much anymore. These two in the middle are called the means. And it's easier to spot when you write it like that because you can see the middle numbers, 1:4, ... Have anybody ever seen that? You see it on racing forms or when you have a lottery ticket or something, these are your odds. So the extremes would be these, the first one and the last one. The means are these two. And then they made a rhyme. I don't know what they think they're doing when they're teaching. The product of the means equal the product of the extremes. That's the rhyme. Here's what it looks like. This product, which is 1 times 20, equals this product. Calling it means and extremes, I don't think does a darn thing. Do you? If you write it in as a fraction.
This makes so much more sense now. Because I try to throw my computer.
I really like statistics, by the way. So I was happy to explain that to you. Did you like it?
It makes sense.
Sooner or later, you'll see it again, and maybe in this course. And so I'm sorry I didn't pick up what you were saying sooner, but that's what they were trying to do. And so I think you could. The extremes are the first and the last, and the means were these two. And the fact.
And what's the mode?
You wanted to finish my statistics?
Actually, it doesn't ask for the mode, but that'd be dope to know.
It doesn't?
These three, median, mean, median, and mode, are the three that they use a lot. The mode is whichever number appears most often.
Oh,
So for instance, 3, 4, 5, 5, 6, 7, 9.
5.
5. And when you look at numbers, if some number is appearing more often, when you put it into a graph, you'll see that jump. I mean, we've been looking at, the virus and how it jumps sometimes. We're looking for things like that, where it went up. And if you had all your data, all your numbers in a row, and then all of a sudden there's a number that's appearing a lot for whatever reason, that's mode. Whatever appears most often. And so your answer would be, the mode would be 5. Sometimes you don't have one, but that's the end of the statistics class. What do you think? Can you get by mean and I don't know why they did that.
Do you teach statistics for Seattle Central and intro?
Yes.
Okay, good.
And I'm doing it now, and I've taught it for a long, long time. The statistics class is well designed, and it was developed in the department. And I've had the best luck getting more and more and more people to succeed with that course. So I have no problem with that course at all.
Can I ask
I
a
was
question
shocked when
after?
I got almost every single person passing. And I thought,
that's
holy
good.
mackerel. Not that you have to work, obviously, but for some programs, it is required.
Yeah, I have to take it eventually. I've got
Medical
to take it.
or dental or science or computers or I don't know what all, lots and lots of programs require it. Mhm. Okay, well, it's almost 10. So what's my final word? My final word before I leave is there's no class on Wednesday because it's a holiday. It's Veterans Day. And so, and also I made sure that everybody had at least 10 late passes. And so there's quite a few assignments due tonight in chapter 5. But if you don't finish them all, then just use a late pass and take a little extra time. And, you know, so everybody has plenty at this point, at least 10. And so just use them, and then I'll see you on Friday. Is that a plan? So I'm going to stop recording because you know me.
Thank you.